Hello, I want to welcome you to today's class. This will form the second lecture in Module 5. And today we'll be talking about types of chemical reactions, as you can see on the screen. As usual, we're going to start this with a beautiful quote. The quote says, "If you study to remember, you will forget. But if you study to understand, you will remember." This is a very powerful quote. I'm not going to say much about this quote, but it is a statement that you have to think over and ponder about. All right, let's go straight to the learning objectives. Today, we have 3 learning objectives that we want to address. The first will be we have to understand different types of chemical reactions. 2, we know how to write different types of chemical reactions and balance them. Remember, in the last module, we actually addressed how to balance chemical equation. And then lastly, we can now predict the product of different kinds of reaction. We can get the reaction, predict the product, and write those products very correctly. Now, what are the types of chemical reactions we're going to be looking at here? Number 1 we'll be talking about is synthesis or combination reaction. We're going to see what this means. We're going to look at decomposition reaction. We'll be looking at combustion, single replacement, or we call it single decomposition, or it's also called substitution reaction, whichever one you want to call it, and we understand why it has all these names. And the last but not the least will be the double replacement. Some people call it double displacement, double replacement, or double decomposition reaction. And there are 2 types we're going to be looking at here. The 2 types will be precipitation reaction and neutralization or acid-base reaction. So these are all we're going to see as we move on in this lecture. The first one, let's take it off from here. Now, a synthesis or combination reaction is simply a reaction involving 2 or more substances reacting to form a single substance. Now, 2 or more simpler stuff. I will say simpler. So you can say 2 or more simpler stuff reacts to form a complex stuff. So simpler substances forms one big stuff. You can say big or complex. As tell my student, whichever one that works for you, you can use one complex stuff. So a very good example here will be, now, if carbon react with oxygen to form, of course, this is a gas, to form carbon dioxide. Here you have 2 single elements combining to form a bigger stuff of carbon dioxide. This is a good example of a combination reaction. Now, a combination reaction doesn't have to always be 2 elements. Like most students always think, it doesn't have to, it can be 2 substances or 2 compounds. A good example is what we have here. If lime, which is a solid, reacts with carbon dioxide to actually form marble, what we call the limestone, calcium carbonate. This is a good example of a synthesis reaction. So every synthesis reaction takes the form of 2 things coming together to react to form one single stuff. Of course, the single stuff you form will be bigger than the 2 previous reactants that you started with. So I'm going to write a general form of this reaction. So we can say that the general form of this reaction will be A plus B will combine together to form A, B. This is a very good way you can look at this kind of reaction. They come together, they form a B. So this is the general form of this reaction. And there are a couple of other types of reactions that you can see happening in this form. Another good example would be this reaction. Of course, carbon dioxide is very soluble, a gas, combines with water. This is what you find in your soda to form carbonic acid. So this is what you find in your soda when you drink your soda, actually. And this is also a combination reaction. We get to the next one. The second one, decomposition. As the name implies, decomposition reaction simply means the opposite of combination. Decomposition, I usually tell my students it is opposite of combination. So if you turn this the other reaction around, what they're going to have is this. So because what it means is that a singular substance, a big substance, is broken down into two or more simpler stuff. So it is an exact opposite of a combination reaction. So if let me start from that general rule. If I start from that general part, remember, if you go back to this, look at the general pattern I wrote. So I can easily turn this thing around in opposite to form the general pattern for this decomposition reaction. So what is going to be is that if I have a complex stop AB, and of course, this decomposition is usually done by heat. This means heat. You heat this thing up and it breaks down into A plus B. This is the general form of every decomposition reaction. You start from a big stuff, you break it down into simpler stuff. Okay, let's get some examples here. Some good examples here will be, okay, if I have magnesium carbonate is a solid, and I heat it up, and it breaks down into magnesium oxide, solid, plus CO2 gas. This is an example of a decomposition reaction. I started with magnesium carbonate, which is big. I broke it down into magnesium oxide and carbon dioxide. Another good example here is that if I start with mercury oxide, I heat it up. Here, in this case, it's going to break down into just mercury plus oxygen. Of course, this is a gas. Mercury, of course, is the only metal that is liquid. You remember that? And then the equation is not balanced. Look at that equation. This is 2 here, so I'm going to add 2 here to balance the oxygen. I messed up my mercury. I'm going to add 2 here, and now the equation is balanced. This is also a very good example of a decomposition reaction, whereby I started with a big stuff and I broke it down into simpler stuff. We go to the next one, combustion. A combustion reaction, of course, a very common reaction whereby a combustion simply means when something reacts with oxygen or bonds in air. And for most substances, particularly of organic origin, carbon dioxide and water will be the byproduct of this type of reaction. So what it means is that if you burn these things, you're going to always get carbon dioxide. It is not in all of them, but for most organic compounds, you're going to always get this product. However, the last reaction we had, now, it is possible for a reaction to be classified in more than one type of classification. So remember this reaction. Let me just take a little bit back to what we did here now. You see, this reaction we had here, look at this reaction now. This reaction is a combination reaction, but look at it, it's an addition of oxygen. Therefore, it can also be a combination reaction, a combustion reaction. So let me start with that. Now, if carbon combines with oxygen gas to form carbon dioxide, of course, this is burning in oxygen or air. Therefore, this is a combustion reaction. We can have another one. If I have my methane gas burns in oxygen, I told you for organic compounds and hydrocarbons, organic compounds, actually, when they burn, they usually generate carbon dioxide plus steam. Now, these substances will always have this pattern. So, just like what happens in respiration, tissue respiration, whereby glucose molecule, which contains carbon, hydrogen, and oxygen, bonds to release carbon dioxide and water as well in electron transport chain. So, if you look at this reaction now, let's see what is going on here. Now, this is methane, bonds in oxygen to release carbon dioxide and water. The reaction is not balanced. There is one carbon, there is one carbon. We have 2 oxygen here. How many oxygen we have here? We have 3. Now, our hydrogen is not also balanced. So let's balance the hydrogen. Hydrogen is 4. If I put 2 here now, my hydrogen is balanced 4. However, my oxygen now becomes 2 plus 2, 4. I can always add 2 here to make sure the equation is balanced. So this is a good example of a combustion reaction. A combustion reaction simply means addition of oxygen. And of course, most combustion reactions can also be classified as combination reaction. So this is also a combination reaction. It is also a combustion reaction, just to let you know. So this is both combination and combustion reaction. Just to let you know that. All right. So the pattern for a combustion reaction could be written in this way. It could be, I can say A is combining with oxygen. I will have to use a green for my general format of reaction. That's what I want to use. I want to use this for my general format of the reaction. So I would say A is combined with oxygen. That's the general format. And it can form AO2. And if it's an organic compound, it can form carbon dioxide and water. So it depends. So there's a format for that. Okay, for organic compound, it's going to be CXHY will combine with oxygen to form CO2 plus H2O. Most organic compound will form this general format. So both of these are combustion reactions. We go to the next one. Single replacement reaction. A single replacement reaction is a type of reaction in which one element comes and kicks out another element in a compound. Now, it is not a fair competition. I always tell students. That's why we give it a single replacement or a substitution reaction. Remember, it's also called a substitution reaction. It comes and takes away another one. The general form is this. Let's have a general form. A is on its own, comes in contact with a compound. Let's say this compound is BX. Now, what does it do? It comes in here, bullies the X away. Now, bullies B away and takes X. So you're going to have AX plus B. This is the form of this reaction. It is actually not a very fair competition. Here, the guy that has the macho and that has the power comes and kicks away the other guy, and the other guy now becomes single. So this is called a single replacement, a single decomposition, or a single displacement, or a substitution reaction. Whichever name you want to give it, doesn't really matter. So let's see some common examples we have here. Okay, I have an example here. Now look at this. In this reaction, let's say aluminum. If aluminum solid, of course, on its own comes to react with HCl. HCl is aqueous dissolved in water. What happens here? Aluminum comes here, kicks out hydrogen and takes chlorine. So it's going to form, of course, you know how to write this. Aluminum is +3, so it's going to be AlCl3 aqueous plus hydrogen is now kicked out. Of course, a pure hydrogen molecule will be H2 gas. This is a case of this type of reaction. Now, what is happening? The equation is not balanced here. Let's see, aluminum is 1, aluminum is 1. Let's see, hydrogen is 1 here. It is what here? 2 here. Now, let's look at our chlorine is 3. So, what are we going to do? You can start from anyone to start balancing it. So, if you want to balance this chlorine, what am I going to do? So, if you want to touch this chlorine, you have to touch your this. So, if you put 2 here, you've messed up your aluminum, so I'm going to put 2 here to correct my aluminum. However, my chlorine becomes 6. What that means is that I'm going to put 6 here. My chlorine is 6. However, my hydrogen is now 6. To correct my hydrogen, I'm going to put 3 here. And this equation is balanced. So this is an example of a single replacement reaction whereby aluminum comes and kicks out hydrogen, forms aluminum chloride, and allows hydrogen to stay on its own. I have another example. Another good example here will be here zinc, solid zinc, an atom of zinc, solid will react with CuSO4, aqueous. This is copper 2 sulfate aqueous, usually blue in color. Now what happens here? Remember, zinc now will come and kick out this. Zinc is more powerful than copper. It's going to come here, kick it out, and take sulfur. So what it means is that zinc will come. Zinc is 2 plus sulfur is 2 minus this. So they will remain. They will form this aqueous. And then what happens here? Your copper is now on its own. So this is another good example of a single replacement reaction. Look, if it's balanced, zinc is 1, zinc is 1, copper is 1, copper is 1, sulfur is 1, and the equation is very balanced. So this is a single displacement or single replacement reaction, whichever way you want to call it. I have another example. I can write another one for you. You don't really lose anything by writing many of them. So we have iron 3 oxide here, solid. Now what is happening here? Look, see what's going on here. Now carbon has affinity for this oxygen. It's going to come and take this oxygen and kick away iron. So you're going to have iron is going to now be alone. Of course, if it comes and takes this, it forms carbon dioxide. So this actually becomes the reaction. So this is a single. If you want to balance this reaction now, let's see what happens here. Now, oxygen is 3 here, it is 2 here. Usually we don't have to, or you having odd number is difficult to balance. So I'm going to put just 3 here, becomes 6. Of course, this is 6 here. If it becomes 6 here now, my carbon is messed up. I can put 3 here. My carbon is correct, of course, but my oxygen is 6 here. To make it 6, I'm going to put here 2 times 3 is 6. My ion is 4, and then I'm going to add 4 here, and now my ion is 4, and the equation is balanced. Now, every reaction you write has to be balanced. Remember this, that equations are written, and they have to be balanced to make them very correct. That is why I put a lot of time in making sure that the equation is balanced. Now, the next one we're going to be looking at is double replacement reaction, or double displacement, or double decomposition, with whatever thing you call it, depending on who is the author. These are all correct names. Now here, this is a fair competition. 2 compounds react in such a way that they exchange or swap their partner element or ions. And now they're divided into 2. The first one we're going to be looking at will be precipitation reaction. A precipitation reaction involves the formation of an insoluble solid. One of the products formed in a precipitation reaction, which is a type of double replacement reaction, will be an insoluble solid. And that insoluble solid is called a precipitate. Remember, it's called a precipitate. In short form, we call it PT. Now, so like I said, in this type of reaction, elements just swap their partners. Let's see a good example of what is happening at this point. Now, let's see. So I have a reaction so that if sodium, okay, I'm going to go back to the red. Sodium carbonate, aqueous dissolved in water. And it usually takes place between 2 substances that are very much soluble in water. They usually start as 2 soluble substances that react to form 1 insoluble and 1 soluble substance. And usually between ionic compound. So magnesium carbonate, if you react with, sodium carbonate react with magnesium nitrate. Magnesium nitrate, of course, magnesium is 2 plus, nitrate is 1 minus. So if they swap their charges, that is going to give us this. And then, now look at what happens here. I'm going to try to use a different color to do this. Okay, if I'm going to use this one. Now look at what happens here. Remember, the metals are usually written first. They are the plus sign, the cations, followed by the anions. Now, this guy, or rather I will say this ion, which is NO3, man, will now go and join this one. Whereas this one will go and join magnesium. What do they now form? What I usually tell students, the best way to predict the product we're going to get there is to break this thing first into ions and then swap the partners. But we're going to get there in some of the problems. I just want to tell you what this will form. Now, I'll get back to my red. If sodium, first of all, look, I can start with anyone. If nitrate goes to sodium, sodium is +1, nitrate is -1. So the formula is going to give us, let me start. It's going to give me sodium. I'm going to give a space in case I need to balance it. So it's going to give me sodium nitrate, of course, aqueous. And then remember I said it's going to result to the formation of one of the product must be an insoluble solid. Now this is usually the soluble one. We're going to determine this with what we call the solubility table plus. Now remember, this is going to join this one, so this is going to form magnesium is 2 plus, carbonate is 2 minus. So if they swap, since their charges are equal, we'll just cancel it. You're going to have magnesium carbon. Now magnesium carbonate is the solid. So you start with 2 aqueous substances. Look at it. This is aqueous. This is aqueous. You now end up with what? You started with 2 aqueous substances, and then you ended up with 1 aqueous and 1 solid. So this is actually the precipitate. We call it PPT. If we want to balance this equation, we can. Sodium is 2 here. Sodium is what here? 1. So I'm going to add 2 here. If I add 2 here, my sodium is 2. I've messed up the nitrate. Nitrate is now 2 here. I go back here, my nitrate is 2, which is coincidentally correct and good. Magnesium is 1. Magnesium is 1. Carbonate is 1. The reaction is balanced. So this is called a precipitation reaction, whereby two ionic compounds soluble in water reacted to form one insoluble solid and then an aqueous one. Another good example will be, so before I do another example, let me now show you the form. Now, the form in which this thing reacts is that, okay, let's write it. So it's going to be AX plus BY. What will it give you? Okay, I'm going to use a different color for this one particularly. Let me use different color for this. So it's going to be AX plus, I'm going to have my, I still different color, BY. So if they exchange their partners, what are they going to form? They're going to form, remember what I said? B is the metals. So that means this will go join this one. So I'm going to have here A, I'm going to use green. You're going to have AY plus, you're not going to have BX. This is a typical case of the general reaction. For what they simply do is just to swap their partners. It's a fair competition. Nobody loses in this relationship. So another good example, let me take another example here. Let's see if calcium chloride, of course, which is soluble aqueous, reacts with silver nitrate. Now, again, calcium will come and take this one. So you're going to have calcium. Calcium is 2 plus. So for it to react with nitrate, it's going to be this aqueous plus silver will now go and react with this. Silver is 1 plus. This will be 1 minus. So the formula is going to be AgCl. And of course, this is the solid. So this is what we call a precipitation reaction. Let's balance the equation. There is 2 chloride here. There is 1 here. Of course, we add 2 here. If you add 2 here, you've messed up your what? We've messed up the silver. To correct the silver, I'm going to add 2 here. If you add 2 here, the silver I corrected, the nitrate is now 2. Fortunately, the nitrate is 2, and we've balanced the equation. The equation has been balanced. If you decide, I've not been doing this since I started this, we can always add your 1 here. You know, it doesn't matter. Add 1 here. It doesn't matter, you know, if you want to add that. So now the second type of precipitation reaction is what we're going to be looking at. The next one, we call it acid-base reaction. An acid-base reaction is a reaction between an acid and base. It is also otherwise called neutralization reaction. 2 compounds also react in such a way that they swap their partners. Now, one thing important here is that one of the products of this reaction must be water. It must involve water, liquid water. However, unlike the precipitation reaction, both of these guys do not form a precipitate. You form a soluble salt and water. No precipitate is actually involved. Of course, it has to involve an acid and a base. An acid is anything that has hydrogen ion as its positive ion. So let's start. So if I have hydrochloric acid, I'm going to write it red. If I have hydrochloric acid here, which is aqueous, reacting with a base, let's say the base is sodium hydroxide, to form, now what happens here? OH is, remember OH is a single polyatomic ion. So hydrogen is going to go join, okay, let me use green to show you. So hydrogen, this guy, of course, is one entity, will go and join hydrogen. And then this guy will go and join sodium. So what do you form? You form sodium will react with chloride. Both of them are 1 plus and 1 minus, so they cancel, which is aqueous. Like I told you, in acid-base reaction, there is no solid form. You only form water. This is the only thing that you form. Plus, then when H combines with OH, remember, just see if one OH combines with H, what do you form? You just form H2O. That's the water. So that is the source of that water. So every acid-base reaction, no matter the acid, no matter the base, must result to the formation of water. And this water is pure water, liquid water. So this is a good reaction. So we can find another one. If we have H2SO4 here, H2SO4, of course, both acids are usually soluble. We react with another one, calcium hydroxide, aqueous. This reaction is going to give you, again, remember, if I want to show you the arrow again, hydrogen is going to go react with this one. Take this one. This guy will go join calcium. So what are you going to form? You're going to form calcium is 2 plus. This is sulfate is 2 minus. So they're just going to combine well and cancel. Plus, of course, you form your H2. I told you for every neutralization reaction, you must form water molecule. Then if you want to balance this equation here now, of course, our calcium is balanced, our sulfate is balanced. But if you look at here, our hydrogen is not balanced here. There is 2 hydrogen here, 2 plus 4. I'm going to put 2 here. That's 4 hydrogen. And our oxygen from here is balanced. Look at it. Here, oxygen is now 2 oxygen here. Oxygen is 2 inside here. And the equation is balanced. So this is another good example of an acid-base or neutralization reaction. We go to the next one. So at this point, we've exhausted this classification. What we're going to do here is now look at some of the problems and then do them. And the problems are easy, particularly for classification. It says classify and balance the equation below. And that says something. It may be one or more classification. It may have one or more classification according to our classification scheme, which is true. If you look at this reaction now, let's balance it first. I can balance it first. 1 carbon, 1 carbon, 1 or 2 oxygen, 2 oxygen. The equation is balanced. So I'm just going to add 1, 1, and 1. The equation is balanced. Now, if you look at this reaction now, you are forming one big stuff from 2 stuff. So this can be classified as what? A combination or synthesis reaction. That is what we have here. Or, again, because it's addition of oxygen, it can also be a combustion reaction. So it has 2 classifications actually. And both of them, any of them, will be correct at this point. The next one, it says, classify and balance the equation below. It may have one or more classification according to the classification scheme. Let's see if it will have more than that. If you look at this reaction now, you find out that ammonium dichromate is going from here, and you start with one thing and break it down into 3 stuffs. That has to tell you that this reaction is what? This reaction is breaking down. We call it decomposition reaction. So I would say this reaction is a decomposition reaction. That's exactly what I have here. A decomposition reaction. And then we balance the equation. We balance the equation. So in balancing the equation, what do? Now, you can count. You can always use your table. Remember, I have a full lecture. The first lecture I recorded in this module is on balancing equation. So you can always refer to that to know how to balance equation using the table method I used. But what I'm going to do here is to use I'm not going to be using the table method in doing this case. So what am I going to do? Let's look at what's happening here. We have nitrogen is 2 here. It is 2 is okay. So I don't have to talk about it. Let me look at my chromium. Chromium is 2. Chromium is 2. That's okay. My oxygen is what here? Now let me look at my hydrogen. Hydrogen is 2 times 4 is 8. How many hydrogen do I have here? I have only 2. So to make it 8, I'm going to add 4. If you add 4, I've messed up my oxygen. Oxygen now becomes 4 plus 3, 7. Oh, interestingly, my oxygen is balanced. Oxygen is 7 here. So I'm just going to add 1, add 1, and add 1. And my equation is balanced. And like I said, this reaction is called a decomposition reaction. That is the classification of, and this is the only, from our classification scheme, this is the only classification this one will have at this point. We go to the next one. Say complete the single replacement reaction below and balance it. No need to add the state. In the next module, we'll be doing ionic equation, whereby we know how to actually add the state of this product and now predict what we call the solubility of those substances. But for now, we'll not deal with a lot of those states. If you have to add the state, I'm going to tell you what is going to go on. Now, what do? We need to remember what I said. In this type of reaction now, we need to form the product. What type of reaction is this? So first of all, I didn't say classify it. Now, if you find this kind of problem, it will not ask you to classify it if you didn't. The first thing you need to do is to say, okay, what kind of reaction is this? The type of reaction that this is it, you have one thing, another one reacting. Well, simply, this guy is going to go kick out this guy. So this is easy for you. So what do you say for yourself? This is a single replacement reaction. So we can call it. So you can say this is a single replacement. So this is a single replacement reaction. That's exactly what we have here. It's a single replacement. One is going to kick. So aluminum is going to go kick zinc out and take the sulfate ion. So now, how are we going to write the product of this reaction? I tell students, refer to the charges. You can always go back to your periodic table or go back to the when we did how to write simple ions. Know what the charges are. So aluminum forms 3+. Zinc forms what? 2+ already. But here we're going to kick it out. So if this guy is going to go to this guy, of course, this guy will go and join this guy. Sulfate is 2-. So what are we going to do? We're going to swap these charges. Simply. That's what we're going to do here. So here we have aluminum and this guy. Okay, let me write it this way. I'm going to make it easy for you to accept. So in the first one, I have aluminum 3+. Here, you break it down to zinc 2+ and sulfate 2-. They're going to swap their partners. This guy will swap. Let me use a color. So this guy will come and connect with this guy. This guy has nobody, therefore he's going to be alone as an atom. This guy has nobody to join with. That is a single replacement reaction. So if this guy combines with this guy, they're going to swap their charges. The 2 goes to aluminum and the 3 goes to sulfur. So what are you going to form? You're going to have, I go back to my red, you're going to have Al, we take the 2, and sulfate, we take the 3. Remember, for any polyatomic ion, if it's more than one atom, you must put a bracket. Plus, the zinc has nobody to join with, so it's going to just go here and become zinc atom on its own. So it's going to be Zn solid. It's going to be on its own. Of course, I didn't write the state. Don't bother about the state here. I didn't ask you to put the state, but I'm going to just put the state. The state here doesn't matter now. So this is the product of this reaction. Now we can now balance the equation. Let's balance the metals. Aluminum is 2 here. We're going to put 2 here, 2 aluminum. We look at this. Zinc is 1, zinc is 1. We don't have problem. But look at this. Sulfate is 3. To make sulfate 3, I'm going to add 3 here. If you add 3 here, my sulfate is now 3. However, my zinc is messed up. What do? And I add 3 here. And the equation is balanced at this point. And we've been able to predict the product that when aluminum reacts with zinc sulfate, it forms aluminum sulfate plus zinc atom deposited. All right, we go to the next problem. In problem 4, it says complete the double replacement reaction below and balance it. Include the states of matter. What is the another classification for this reaction? Now, look at the hint. It says what? Phosphate salt is soluble. So we know we're going to have a phosphate salt here. It's going to be soluble. That's going to tell us what the product is. Remember, in this type of reaction, we're going to give you the classification, right? It's a double replacement reaction. And I told you there are 2 types of double replacement. There is acid-base and there is what? There is precipitation. If you look at this now, there's no acid and base here. So basically, this reaction is going to be a precipitation reaction. That's what we're going to have here. This reaction is going to be a precipitation reaction. So, and every precipitation reaction involves the formation of a solid. And we've been given a hint of what the solid is going to be. It's going to be anyone that contains the sulfate. So let's try to write what we have. Again, I'm going to break these 2 down. So this will involve magnesium 2+. And break this is nitrate ion. Nitrate is 1-. This one contains potassium, is 1+ in group 1, and phosphate is 3-. What is happening here? Let's see. The exchange now happens. Magnesium will now go and take this guy. These 2 will combine. These 2 will combine. So if magnesium goes to this guy, magnesium is 2+, this is 3-. They're going to exchange. So what am I going to have? I'm going to have Mg. Wait, let me give a space in case the reaction will be balanced. So it's going to be Mg. It's going to take 3 from phosphate, and phosphate is going to take what? 2 from magnesium. Plus, this will go to this. This is -1, this is +1. Therefore, their charges is going to be just cancel out. Now, the reaction says phosphate is the solid. Therefore, this is the solid. If one is solid, what it means the other one is going to be aqueous. These are the product of our reaction. So here, magnesium nitrate reacts with potassium phosphate to form magnesium phosphate, which is the insoluble or the precipitate, the PPT, and potassium nitrate. So now let's balance this equation. Like I said again, I'm not going to use table. I'm going to start. My magnesium is 1 here, is 3 here, so I'm going to add 3 here. If I add 3 here, I've messed up my nitrate. I want to fix it. My nitrate now becomes what? 3 times 2 is 6. I'm going to just go straight and add 6 at this point. So I now have 6 nitrate. But something is messed up again. My potassium is messed up. I'm going to go fix it. 6 potassium. To fix it, if I add 2 here, it becomes 6. And again, my phosphate is messed up. So this is 2 phosphate. I go this way. My phosphate is 2. And the reaction is balanced. So I can always add 1 at this point. So I have been able to classify this reaction as a precipitation reaction. I've written the product. The product are magnesium phosphate and potassium nitrate. And what else? I've balanced the equation. And these are the things you expected. So you can always pause this video, try out these problems, and come back again and check your answer for correctness and perhaps proper comprehension. Now we go to the next one. The next one says complete the following double replacement reaction. Again, in this double replacement, an acid is known by starting with hydrogen. So this is an acid-base reaction. Of course, I'm going to say immediately this is what? An acid-base reaction. So this is acid-base. Or you can say neutralization, whichever one that you want to use. They mean the same thing. Again, how do we predict the product? Always go back again for my table. Hydrogen is always 1 plus. When it is acting, when you find it in an acid, it's a positive cation. Now, what else? Sulfate is 2 minus. Barium is in group 2, is 2 plus. OH is 1 minus. So now, these two guys are going to swap. So we're going to swap this to this and this to this. That's what we do. If that happens, what goes on? You're going to form 2 products, of course. You can always want to write them out first. So if this guy remember, we said in every acid-base reaction, water is one of the products. So you found that H2OH is water. So this is easier for you. So you can even write that first. Let's just write that one first. So this is going to be H2O, liquid, plus. Now, if this combines with it, this is 2 plus, this is 2 minus, this is 2 plus. That's just going to cancel out. So you're going to have basically BaSO4. And of course, this is going to be aqueous. Remember, you don't have any solid in acid-base reaction. In acid-base reaction, you don't have any solid there. So now we balance this equation. Hydrogen is 2 here. Hydrogen is 2 here. Right? Okay, no. Let's start with barium. Barium is 1. Barium is 1. That is better. Sulfate is 1. Sulfate is 1. Then let's go to hydrogen is 2 plus 2 is 4. Here it's 2. So I'm going to add 2 here. If you add 2 here, it is now 4. Let's see if oxygen is balanced. Oxygen is 2 inside. Now oxygen is 2. This reaction is actually balanced at this point. So you can always put your 1 in front of these ones. The reaction is balanced. So 1, this is an acid-base reaction. And we've predicted the product to be water and barium sulfate. The next problem. Now, the next question want to tell us other ways we can classify reactions. Reactions are classified in 2 basic ways depending on whether they absorb or release energy. Those reactions that actually release energy as a product, we call them exothermic reaction. So most combustion reactions are exothermic reactions because it involves the release of a huge amount of energy. That is why it is possible for you to grill with your propane, because burning propane in air, in oxygen, releases a huge amount of heat that helps to cook your meat. So this is a good example. When water molecule burns in oxygen, this is a combustion reaction or combination as well. It forms this now and heat. Now, see, a very key thing you need to notice here is that in this type of reaction, heat or energy is written as a product of the reaction. Heat must be a product in an exothermic reaction. And then 2, endothermic reaction is one that absorbs heat. So what it means, it takes heat from the environment. If the reaction takes place, you find out that what is going to happen is that the environment of the reaction, where the reaction is taking place, is going to be colder than when it started. Now, how do we know this kind of reaction? In this type of reaction, heat is a reactant. Most of this type of reaction needs heat to take place. If you don't bring heat to them, they're not going to take place at all. So what it means is that after the reaction, they're going to absorb heat from the environment and the temperature is going to drop. And this is actually used in important application in sports. Most emergency cold packs are made with this idea, because when the reaction takes place, it gets colder, and someone who has a kind of sprain can easily use it and put on the spot, and it gets cold and suit the pain. This is actually what happens in emergency cold packs. In this case, again, I said heat is a reactant of this reaction. In exothermic reaction, heat is a product. So let's go and see what happens. This problem says when heat is released or liberated. Remember, if heat is released or liberated by a reaction, that means it's an exothermic reaction. So what it means is that the reaction will be classified as what? Exothermic. It's releasing heat, because heat is written at the what side? At the product side of the reaction. So let's see where that happens. Exothermic and product. Let's see. Exothermic and product is B. We got it. Exothermic and product is B. That is what we'll have there. So now we now go to the last problem in this chapter, problem 7, which happens to be the last but not the least of our problems. It says commonly used cold packs or emergency cold packs involves the reaction below. The reaction simply is when ammonium nitrate dissolves in water. Now, most of these cold packs contain one part of water, one part of ammonium nitrate. So usually when you break it, it mixes with water. Look at the water. It mixes with water, and then you find that it begins to get cold. When you smash it, usually that's why you have to smash it very hard for it to break and mix. Now, when it does happen, look at that. This reaction now, you see heat is at the right side of the reaction. What it tells you is that at the end of the day, the temperature is going to drop. That's why you feel cold when the temperature drops. It now says, classify this reaction as endothermic or exothermic and give reason. Now, this reaction, because heat is at this side, is going to be endothermic. And the reason, what is our reason? Heat or energy is a reactant. And that is why we classify this as heat is a reactant. Okay, let me write that in very well. Heat or energy. Heat, this is heat or energy. I'm going to rewrite those things because I have the time to do that, so it doesn't matter. Reason, I'm going to say heat or energy is a reactant. That is why this is an endothermic reaction. So this will be our last problem. Once again, thank you for listening to these problems. Like I always advise students to do, pause this video at intervals, watch these videos, practice these problems, and then always come back to check for your answer. Thank you once again for listening. Do have a wonderful day. And if you want to contact me, do not forget the usual channels, either through email or walk into my office anytime you have the time. Once again, thank you for listening, and bye.